Hi, this is Andrew. Thanks for joining me. Today I have a video about VLAN concepts, how they're used, why they're used, what purpose they serve, that piece of it. Part 2 of this video will cover the configuration of VLANs, how to make them work, what commands to use, and all of that. So let's start by looking at this picture that I have here. We have two switches and a router in the middle. Obviously nothing's plugged in, nothing's turned on, it's just all there, but this will give us something we can draw on and we can kind of explain the concept. Let's start with just this top switch. Imagine you have this top switch and you want to plug in, say, 20 different devices. We'll call them 20 computers. You just plug them into the 20 ports and now they can talk to each other. But let's say that 10 of those devices belong to one department, say information technology, and 10 of them belong to manufacturing. And you don't want those to be on the same network. You want them isolated for some reason. That reason could be security, that reason could be network performance. We're not going to get too involved with the reasoning behind it because that's a design concept. But just understand the concept that we want those separated. We want them on separate networks. It could be that one is 192.168.1.0 and one is 172.16.1.0, and they're separate networks. They might be able to talk to each other across a router. That's not our concern right now. Right now our concern is how do we keep them separated on the switch? The first obvious answer is we buy a second switch. So now we would have, let's say, this whole switch is IT, and this switch down here is manufacturing. So all the ports are here. We have IT, we have manufacturing, and that's the way everything's configured. Problem is that's a little bit wasteful because we have 10 computers and 48 ports. So we just bought an extra switch we didn't need. There are other problems we'll get to later on. So let's clear that out and start over. Let's say we're just looking at the top switch. We have a floor that has 10 manufacturing people, 10 IT people. How do we keep them separate? Well, what if we take this portion of this switch and we say this is going to be one network? We're going to call it a VLAN, a virtual LAN. And from here, we have the wires going out to the IT computers. And then we're going to configure this portion of the switch to be manufacturing. And we have those going out to the manufacturing computers. And instead of calling them IT and manufacturing, we're going to give them just numbers. So I'm going to call this one 10. And I'm going to call this one 20. So what that does is we have VLAN 10, and that can be IT, that can be manufacturing, that could be whatever we want. And we've now separated this switch. And typically these numbers will match up with some type of addressing scheme. 192.168.10.0, 192.168.20.0. We might have some more ports here that we need to put somewhere else, or we can say, hey, we've used up all 12 of these ports. We need a few more ports for IT. So now we're going to say these two ports are also IT. There's nothing that says the ports have to be configured together. It could be that we also have a server or a printer down here, and that's IT. And then we also have manufacturing has a couple of big printers that go here, and maybe some other device here. We can configure the switch however we want. And ultimately, when you look at the switch or the way the switch performs, these are completely separate and isolated networks. Now let's say we also have human resources comes into the mix. And we need something for them. So we'll create a VLAN here, and we'll call that VLAN 30. And in VLAN 30, we just have 6 ports. We can do any combination we want. Now, imagine that we have 2 floors. We have this switch, this is switch 1, and that is on the first floor. And I'll put a 1 right here. And we have switch 2, which is on the second floor. Now on the second floor, we have, say, 5 IT people. So we'll do a block of 6 ports there. And there's a lot more in manufacturing. So we're going to do all of this as manufacturing. And then, let's see, we have some HR. So we'll do HR here. So now we have all of those ports. Now these are going to be configured as, all of these are configured as access ports. They can only access a single VLAN. And that is, these wires will come out and go to a single device. Now the question is, how do we have VLAN 10, all of these ports, being able to be on the same network as this switch, these ports right here? What we do is we create a trunking port. And that trunking port can carry whatever VLANs we want between switches. So what we're going to do is say that we could do it on a regular fast Ethernet port. We could do it on a gigabit port. So we're going to do it over here. And over here, we're going to say that this port 2 can go down to this port 2. But we're going to say it can also carry traffic from here and traffic from here. So now all 3 VLANs are traveling over the trunk port. We can't plug a PC into this, but we are connecting the 2 switches together. So we have separated this switch into, in this case, 3 virtual switches, 3 virtual networks, and then combined the 2 switches so that across the floor, all of the IT people are on the same network, all of the manufacturing people are on the same network, all of the HR people are on the same network. And if later on we need to add something else, we can just say, okay, we have QA on this network as well. Now this might be 40. Let's put the number here. And we might not need 40 up here. So we might not need to have it go over the trunk port, but let's say we want it going over the trunk port, and then we're going to have a single QA person here. Now we have 40. Now we might have a couple of security cameras that we don't want on the same network. And if I had enough colors, I could say this is where we'll put our security cameras, and we'll put our security cameras here, and then we'll also have that going down. So now we have 5. And you can see how if we didn't have this trunk port, what we would need to do is we'd need to set aside a port to connect VLAN 10, a port to connect VLAN 20, a port to connect 30, and a port to connect 40 and 50. So we just wasted 5 ports on each switch instead of 1 on each switch. And we'll see that when it comes in, when we get to routing. So let's say we're all happy now, we have 5 VLANs. And now we want to actually talk between them, because right now these are separate networks. It's like we have 5 separate switches that are not connected at all. So we have 3 ways to make the all of the switches talk to each other, all of the VLANs. I'll go with start by explaining the legacy, the unused way of doing things. And that is just to say, I'm going to take a wire from each VLAN and plug it into one of the ports on the router. Now the problem here is it becomes really a poor use of resources to say that to have 5 VLANs, we need 5 wires going from switch ports, and we need routers at 5, 10 ports on it. And in this case, we have 2 Ethernet ports, so I even plugged into serial ports, assuming we would pull that out and plug in Ethernet ports there. So it's just completely non-functional when you get beyond a certain level, and really not the best way. Option 2 is called router on a stick, and that is what they consider the best case for small environments, and that's what we're going to take more of a look at in a little bit. Option 3 is really the real world situation, and it is called layer 3 switching, where you have a switch that can do routing. It can do routing between VLANs. So if one of these were a layer 3 switch, it would actually be able to, you would be able to configure it to say, VLAN 10, VLAN 20, we have virtual interfaces for all of these. You will see that in the packet tracers for Module 4. What I'm going to demonstrate or draw a picture of, because it's easier to visualize, is the router on a stick option, which is the second option, the small to medium size non-scalable option. Now, right here we have a trunk that goes between VLAN, between switch 1 and switch 2, and it carries 5 VLANs. What if we do the same thing going to the router? We could say we're going to have, this is going to be a trunk port, and it's going to go down here. And we have our VLAN 10, and now we have our VLAN 20, and we have our VLAN 30, and even VLAN 40 and 50. So now what happens is if VLAN 10 wants to talk, it's going to communicate out of the trunk port down to the router. The router is going to say, this is coming in on VLAN 10. Based on addressing, if I look at my addressing table, it needs to go back to the switch on VLAN 20. So it sends it back with a VLAN 20 tag and gets to the blue ports. And if it needs to go to VLAN 30, it goes to the green ports. So this is the process that we're going to follow. And if you look at what we're doing here, it really involves just configuring ports as either access or trunking ports and telling it if it's access, which VLAN is it on. And there's something called native VLAN that you will see in the reading. That's where there's no tagging at all. And the router needs to know what the native VLAN is, and there needs to be, it needs to match every place it's connected. So we have all of these VLANs, we have a native VLAN where there's no label on the port. And what we're doing is we're saying all of these are, each one of these acts as its own switch. If a broadcast is sent out on 10, it goes to all of the red ports. But it doesn't go to any other ports on the switch. So this is the process we set up. If you look at it, we set up access ports with their VLAN. We set up trunking ports telling it which VLANs that can be used. And this is exactly what you're going to see in the reading. There's a lot more, there are a lot of details that go beyond the scope of what I'm covering here. Definitely do the reading, make sure you understand that. But this is the key piece of why VLANs exist, what they're for, why we want to use them. So stay tuned for part 2, where I'll show you how to do a configuration. And that's all I have for you until we get to part 2. So thanks for watching.